You are welcome once again. We started discussion on descriptive statistics 2 days ago, and so far we talked up to summarizing categorical or qualitative data. Today we want to wrap up the lecture on descriptive statistics by talking about how we summarize quantitative or numerical data. You see, just like what I told you the last time, 2 days ago, it's quite easy to summarize categorical variable, categorical data, because by nature, there are manageable categories of output. I mean, the possible outcome, outcome I wanted to say. For example, for sex, male and female. So even if you are dealing with 1 million people, you just to count how many are male, how many are female. You put the value over the total for a male, over the total times 100 to know the percentage. The same thing for female. The same thing for ethnicity. We have manageable category, number in each category over the total. It gives us the percentage, which is relative frequency. So that's just it for categorical variable. And mind you, if you have quantitative variable, you can see categorize it also. But when you categorize it, it becomes categorical. It's no more quantitative for age now. Age as raw age is quantitative. But when you begin to range less than 20, 20 to 25, 4, 25 to 9, 29, all those are now tabulate. The age range is not numerical again, it's categorical. Of course, for each of the class, you can know how many fall in each class and know the percentage. Can you see? So that just is. So summarizing categorical variable, use proportion percentage. And that percentage I've told you just one of them is the commonest. So we can use male-female ratio. You can use ratio for anything. Worker-employee ratio, all those things. You can do it. And if you use proportion, which is part of the whole, and time is included, is called rate. That's all. It's so simple for summarization of categorical variable. But when it comes to quantitative, there are this one I'm showing you are the 4 ways of summarizing them, 4 different ways. And each of these will also have many types under. So first one is measure of central tendency or measure of location. Second one is measure of dispersion or measure of variability or measure of spread. Third one is measure of relative position or quintile. Then the last one is measure of distribution shape or called shape. Now, let's unpack each of them one by one. The measure of central tendency, there are 3 of them. What the researcher actually wants is to look for one value that is close to the middle that you can use to represent everything. Imagine you have samples of 400. You measure weight. You cannot come and be listing the weight one by one for us and say, Mrs. Eunice this, Mrs. Amina is this, Mr. Aruna is this, Mr. Gabriel is this. This is the weight. Begin to list 400. Or what uses statistics then? You want to summarize. Somebody looking for one value that will just represent all of them. And over the year, the intelligent people are thought of different ways of doing that. The first one is the mean. Mean just means that you add all the value together and you divide by the total number. It's very simple. That is what they call average in arithmetic. But actually in statistics, mean, mode, and median are measure of average. All of them are average. But what people know as average is the mean. But the mean is just one of the 3 averages. So it's a simple one. It's very simple. Well, all of them are simple anyway. But it's quite simple. You add all the value together, you divide by the total number. So sometimes what scare people away is the formula. Look at here now. For this, you can have 2 ways of representing the mean, of calculating the mean, depending on the scenario. So you can have group and ungroup. Ungroup just mean when you have manageable number. Imagine now you have 15, 10 value. You want to have, you can add them together easily and divide by 10. Or if there are 15 number, you divide by 15 and calculate the average. But when we are dealing with 180, you know that some of them may be, of course, you're going to see one that recur among them. So you try to group them. We now become group data. You may say, okay, how many way between 40 and 44, 45 and 49, 50 and 59, like that. You now begin to tabulate them. But that's what we call group data. But to me, it's useful in the realm of just understanding it, because well, sometimes when we give you statistics, you write it down, you still have to use your hand to calculate it. But with the advent of computer, even that one, that using hand to calculate group mean, using group data, you can see there's limitation. You cannot, nobody can give you 4,000 unless if the person have already summarized it on the table for you to now calculate. But they not give you 4,000 value, begin to, even 1,000, begin to sort out. No. But before they can give you 40, 80, and you sort out. But nobody will give you. And a computer, make it easy. Even if they are 1 million, computer will run it. So to me, just know the average is mean is addition of all the value and divided by the total number, which is the sample size. The advantages of the mean and mean, well, is worth knowing. The advantages and disadvantages of mean. Advantages of mean: simple to calculate, it's very simple. Used for further statistical calculation. That is one major thing. Among the measure of average, mean is the one that is most useful for further statistical calculation, followed by median. Mode is not so much useful like that. The mean is the number one. In fact, if you can understand descriptive statistics and understand the logic behind that mean, and later we talk about standard deviation and well, everything, standard deviation, variance, and then the sample size, standard error, degree of failure. Those are the things. Even in advanced statistics, those are what they are playing around. In advanced statistics, they play around the mean, standard deviation, variance, sample size, standard error, the degree of failure. Those are the things they play around. So we'll look at all of them. Now, used for further statistical calculation, all the values in the data are taken into consideration, therefore more representative than mode and median. That is, in calculating the mean, all the value are, so every value contributed or contributed, relatively reliable because it does not vary much when repeated samples are taken from the same population. So there is sampling error, small sampling error. We'll still talk about that, all those error. Now just know that the mean of sampling error is because you want to know something in the population, maybe you want to know the mean age in the population or the mean weight in the population. You cannot attend to all the elements in the population as I've told you before. You take sample, just take few of them. So the sample, whatever you calculate from the sample, is an estimate. It's a statistic. You know, I've already told you the summary of sample data is statistic. Summary of sample characteristic is statistic. So if we say mean of weight from your sample is statistic, but the mean weight in the population is a parameter. So you are actually interested in the parameter. But the sample, what you get from the mean, which is the statistics, is an estimate. Now, the difference between that one is the sampling error, because you have taken sample, because you calculated for sample, that is sampling error. And the more you increase the sample size, the sampling error decreases. The closer, as you increase the sample size, the value you get will be closer to the real parameter. So the sampling error decreases if you increase sample size. Dr. Kende Oguntoyinbo, in moot. Disadvantages of mean: take longer time to be calculated. It takes longer time to calculate because sometimes that's if you are calculating with hand. The computer, it doesn't take any longer time for computer to calculate it. So no, not easily understood by non-statistician. People don't understand it. The listing also is one of those things also we in number 3 and 4 and 5. Does not always represent actual score belonging to some member of the population. So one of the reasons that is not easily understood is that imagine now you have number of children in family as your variable, and you collect number of children from different family. So you can only have 1, 2, 3, 4, any whole number. You cannot have 2.5 children. Then by the time they calculate the mean, they say it's 3.5 or 3.23. So can you see it look funny? So because it does not always, not all the time that the value of the meal is something any member in the population can actually have. So because of that, that's one of the reasons the non-statistician don't understand that the mean number of children in the family is 3.4. So we begin to look at you. Then when used with discrete variable, it's often yield unrealistic value. It's still the same thing. So the example I've given now is a discrete variable, number of children. You know, I've already talked about number of children. But if you talk about the blood sugar, it's not a discrete variable. So when you use it, okay, to calculate numerical discrete, it gives you, numerical discrete is usually a whole number, but it will give you decimal. So then affected by extreme value outlier. That is, if you have extreme outlier, we still talk about outlier. Outlier are values that are significantly different from the other. For example, in this class now, if you are to calculate maybe your average weight, yes, you may say that the people in this class now, the average weight may be around 75. Those, some people will be big, some people will be small, they will weight less, maybe 75. Imagine in calculating somebody, maybe Dr. Kennedy, just brought a 5-year-old daughter to join, and that one will now maybe weigh something like 12 kg or 15, maybe 40 kg or 13. And if you had it, and you calculate it, assuming that okay, is part of the member of the class, it will slash the mean down because it's an outlier. That girl is an outlier in the sense that her weight is significantly different from the rest, significantly lower than the rest. Because of course we know that for the whole class you don't have the same weight. That's why we are calculating the mean. Your weight differ from one person to the other. Then when we say a value is significantly different, so that is far different. So it can be significantly smaller than the rest, like this or the girl. Or maybe you have somebody that weighs over 150 and is part of the class also. So that one we jack up the mean. So that one is significantly higher than the rest. Whether significantly smaller or higher, that is an outlier. A value that is significantly different from the rest is an outlier. So when there's an outlier, it will affect the mean. It's affected by extreme value. So mode is, if you list values, many values, there are some of the values that we recall for the weight now. You see many people weigh 70, 70, 70, 70. Some people may weigh 80, 80, 80. We have many people that weigh 80 or 70 or 75. The most of it, or 65. The most of the time, it may be another 70 or 72 that major. You have a lot of people that weigh. So the value that occur most frequently is the mode. So all this formula, just forget about it. That one is just for academic purpose. When you are now dealing with group data, how do you calculate? Because normally, if you just put you arrange them in ascending order. If it's a manageable number of data that maybe it's not much, you can arrange them and you see which one appear most. But when it's plenty, you put in table, you range it. In that situation, now you have already ranged. You are not putting. Individual value are not there. You just tell that from 80 to 90 is that 15. You don't actually know the actual weight of those 15. In that situation, those are the time they use this rigorous formula. Me, I don't ask anybody, even at postgraduate level, I don't ask it because to me it's useless. Because I would rather teach you. You just know the logic. Teach you how to use machine, how to use SPSS data to run the analysis. So now, advantages and disadvantages of mode. Now, it is easy to calculate. Well, some people say that one is easy to recognize because if it is you're talking about group data, to me it doesn't. It's not easy because those formula can destroy people. So, but if it is not group formula, it's easy. You don't need to calculate just to know which one appear most. It's easy to recognize. It often represents an actual score belonging to some member. That is, what you see there is number. If you say the mode is 15, so that's that some people you can see that some people have that 50 as the value. So it represents actual score, not affected by extreme value. So it's not affected by extreme outlier. If we choose the mode, it doesn't really matter. And like the weight I talk about, if we now have the mode, so whether extreme outlier come, maybe a small girl join or someone that is big join, it doesn't affect me. In as one that those ones they are not part of the mode. So it will not do anything. So for qualitative data, only mode can be meaningfully employed. What do you mean by that? For example, now, if you list ethnicity, you now say, okay, you now list Hausa, Igbo, Yoruba. Maybe depending on where you are doing the study. If you are doing the study, it may be in the Katsina or even it may be in Kaduna, or you don't do that, Hausa, or that. You may see that for each of them, are we together? Each of them, we may have many categories. You may have a category that, maybe 20, maybe, well, it doesn't even depend. Maybe in that situation, Igbo is 20%, Yoruba is 20%. Can you see now? So that particular, number, that is number of Yoruba, the frequency of Yoruba and Igbo is this. In that situation now, that is the mode. It's a which ethnicity, appear that's not the logic. The logic is which the one that have the highest frequency there. Maybe in the Hausa that have the highest frequency in that place. Maybe you do in Kaduna. Maybe you now see 56% or 70-something% Hausa or 60-something%. Then the other one they now share. So the ethnicity that appear most is, so that is, if you look at it, this mean mode and media is to summarize quantitative data, but it's only mode you can use for categorical data. Is it your, because I say your daughter, you now send your daughter to be writing on the screen or what? Okay. Now, disadvantages of mode, it represents a misleading picture of distribution that does not have a regular shape. Can represent a misleading picture. Now, not representative because not all data are considered. It's not all the data sets, all the elements in the data set you use to calculate, unlike the mean, may not exist. Mode may not exist. If all of them, all the values, they have the same frequency, that shows that there's no mode. All the values, they have the same frequency. Maybe you are dealing with let's say you are dealing with 60 people, and you now see that all the possible values there that appear, they are like 15, and each of them have apply 4 times. In that situation, there is no mode. Then it may not be unique. Yeah, it may not be unique in the sense that you may have two modes. You may call it bimodal. You may have, maybe we have two different values that have the same highest frequency. So in that situation, it's two mode. You will have three different numbers that have the same highest frequency. That's trimodal. So doctor here, you remember there is one, what do I call it? One cancer, Hodgkin lymphoma, that is bimodal in distribution. It peaked among the around age 65 and pediatric age group. Now, the media, what do you do? Okay, mode. Okay, let's now go to media. The media is the one in the middle. If you arrange it in ascending order, the middle value, if there are 25, if you arrange in ascending order or descending order, if you start counting from both sides, it's number 13. Any of the side, number 13, that would be the median, because the middle, if you see 12, 12 times 2, 24, so it's number 13. But if you are, let's say they are 24, it's going to be number 12 and 13, because you will not have one figure. If they are even number, odd number, it's only one in the middle that will be in the middle. But if they are even number, maybe they are 24, it's going to be number 12 and 13 that will be in the middle. In that situation, you add the two together and divide by 2. So you calculate the average of the two. So this formula you see here is for the one down, for the group data, just like the way you see in the mode. So don't bother yourself. So actually, the computer do all those things for you. Advantages and disadvantages of median. Advantages of median: it is easy to calculate. It often represents actual score belonging to some member of the population, just like the mode, not affected by extreme value, easily understood by many people. So actually, all the advantages of mode and median, they look similar in many respects. Disadvantage, not representative because not all data are considered. It's the same thing with mode also. Now, geometric mean. Well, this one has been in my slide when I do the workshop also. So this means an excellent summary measure for data which are approximately normally distributed. Sometimes we collect data which are not normally distributed. So all these things we just talked about, they are good for normally distributed, especially the mean. But if you are dealing with something that is not normally distributed naturally, it's not as if there is outlier. So, for example, if you follow logarithmic, if you are dealing with reciprocal, that is 1 over something, that kind of thing does not follow normal distribution. It follows logarithm distribution. So geometric mean is an or average of a set of data measured on a logarithmic scale. That is, you calculate the average of something you mention on logarithmic scale, not on normal scale. So the formula, let's leave that one. Now, harmonic mean, that one defined as the number of observations divided by the number or reciprocal of the value of the set of observations. It sometimes provide a better average than the arithmetic mean. It's calculated harmonic mean is this n over sigma 1 over the sigma of the reciprocal. There are situations you use it, but don't leave that one. So look at this picture. This picture just try to show you the relationship between mean mode and median. We're talking of the arithmetic mean. The mean, median, and mode will coincide in unimodal distribution that are symmetric. So the meaning of symmetry. So actually, the way this graph you see is plotted is this. Horizontally is the value of the variable you are dealing with. When we use this weight, you measure it from left to right side. So from the beginning of that line to the right, as the age increases, it will be increased, or weight increases. The vertical is the frequency, how many in that category. So when you see a graph goes down and come back, what it means that most of the time, though when we get to normal distribution, probability and normal distribution, we explain it for better. What this one is just showing is when you plot value along the horizontal and the vertical frequency, most biological and social science variables, naturally occurring variables, they follow a pattern. And the pattern is that as you increase, as the value increases, for weight, example now, weight, as the weight of adult increases, I'm not talking of children, adults, as the weight of adult increases. That is, as you are getting somebody that has higher weight, the frequency, the number of people in that category that have the higher weight increases also. So those attributes, as the attribute increases in value, the number in the society that has it increases. That's why the graph is going up. It's going up. it reaches a stage when maybe weight now, maybe when it reaches 70 kg. Like for example now, somebody, few adult weigh 40 kg. More adult weigh 45 than 40 kg. More adult weight 50 than 45, 50 kg than 45. More adults, more number of adults weigh 60, 65 than 50. More adult weigh 60 than 65, 55. More adult weigh 65 than 60. More adult weigh 70 than 65. But when you read that 70, when you go further, 75, you may see that less adult weigh 75, less number of adult weigh less 75 than 70. Less adult weight 80 than 75. Less adult weight 85 than 80. Less number of adult weight 90 than 85. Can you see that? Of course, few one weight 90 and 100. So you will see the value of the level, and the frequency start coming down. The way it goes up is the way it comes down. That's the first graph you are seeing. We now see it look bilaterally symmetrical. The meaning of bilaterally symmetrical is that if you divide it into two in the middle, one side is the mirror image of the other. That's for something that is normally distributed. And the mean and the median and mode will be the same. That is, if you calculate the mean, if let's say wait now, the mean is 70, the mode will be 70 also. That is, if you arrange in ascending order, the value that, even if they are, let's say there are 400 people or 1,000 people, if you arrange the value in ascending order, of course, some will have the same number. That value that will be in the middle will be the value that mean. Will be that mean. Now, if you know, because many of them will have many scores, the one that highest number of frequently occurring value, that value that is most frequently occurring, which is the mode, will be same mean and the median. So that's why I say mean, median, and mode are the same in this a variable that normally distributed. Now, once there is an outlier, as I have said, once there is an extreme value, some extreme value that are different from the other, it will skew it. It will not make it to be symmetrical. That's what you see in the second one. The second one now, you will see that you see the mode, the median, and mean. The mean in the middle one now, we have a positive outlier, a value that is significantly higher than the rest. In that situation, because when you add everything together and divide by the total, it gives you a value that is higher than what it would have been, because that person has contributed much to the total value. So, and it's still representing one person. So in that situation, the mean will be the higher value. So the thing will now be flat. It will be skewed. That is, it will be skewed to the right. To the right. Now, the third one now is when you have negative outlier. When you have value that is extremely smaller than the rest. So if you calculate, you had everything together and calculate the mean will be smaller than what it would have been. So the mean will be smaller than median and mode. The median is usually in the middle between median and mean and mode. So the one that is close to the peak of the graph is the mode. Of course, you know that. So can you see now? So this is the shape of the graph. The first one is bilaterally symmetrical, so it's perfectly normally distributed. Then the second one is skewed to the right. It's positively skewed because there's an extreme outlier, bigger value, extremely large value that is in data. That's why the third one is negatively skewed to the left. There's an extremely lower value. So now, this example for class. So we have talked about the measure of central tendency now, or we call the measure of location. Now, let's talk about measure of dispersion. Under this category, you have range, mean deviation, variance, standard deviation. We still have one interquartile range, but we'll talk about it later. Now, let me first of all give you the logic behind measure of dispersion. You know, I told you for the measure of central tendency, the researcher want to know was looking for a value that will represent one value that will represent the rest. Now, it has been discovered that the measure of setter tendency, mean, mode, and median, is not enough to describe quantitative data set. It's not enough. Well, let me give an example. If we are talking about distribution, no, we talk about this. That's the first thing we're talking about in this descriptive statistic is concept of distribution. Imagine now somebody come to your clinic, and some people that come to your clinic, you mentioned their systolic blood pressure. You know, the average systolic blood pressure of people that come to your clinic, the level of mercury. Another colleague of yours now say, average systolic blood pressure of people that come to his own clinic is 115. Does it mean that the distribution of the people that come to each clinic the same? No. For the fact that they have the same mean, measure of center tendency does not mean that the distribution is the same. For example, you may have in one clinic, the average is 115, but the value, most value may be around that 115. Maybe the value of that's the average. The real values of those people you use to calculate the average may be around 140, 110, 120, it's around 115, 116. These are the days of using digital now. The rounding of, in the hospital in those days when you use digital analog. So they also is either 115 or 120. Nobody will tell you it's 117. But now you can have it. So let's say the average is 115 and the value are around that 115. Some of them are less small, some are more small. Whereas the other clinic, yes, the average is 115. You may have extreme value of even 19. No, 91. And you have other extreme value 150. You will see extreme value on both sides. And both of them, the mean, when you calculate the mean, is 115. Another example I can give for people that are non doctors, where another example we can give. Imagine you want to know the best student in your school, maybe in the school, in your class, and this student they take nine courses, and you now have to pay student that score average overall 80. How do you know the best? You want to give price. So if you check very well, you may see one. Yes, the average is 80. The person score may be around that 80. 78, 76, 82, 83, all those scores. By the time you calculate the average, is 80. While the other one, you may score 40, 50, 100, 99. And you see, but when you see do it, the average is 80. So that one that is more consistent, the value, the spread is not much. That is, the spread of each value around the mean is not much. While the other one, the spread is much. So both of them, the distribution are different. So that is why the measure of setter tendency, mean, mode, and median is not sufficient. We need to know how spread are they around the mean. And that's what brought the measure of dispersion, or measure of spread, or measure of variability, the same thing. So the simplest one, and the way to know them, is after you have calculated the average. You cannot know measure of dispersion, you have to first of all calculate the average. When you calculate the average, you want to know what is the difference between each value and the average. So that is why, though the simplest one is highest value minus lowest value, that is range. You want to see the distance between the highest value and the lowest value, that is the range. Then the mean deviation is the difference between the mean and each value. So for us to describe the variance and standard deviation, we need to move and talk about that range. We need to move and give example. And let me use this example. So let me stop sharing and share again, so that so I can even remove the. Let me use where is the duster? Okay, I cannot. Okay. So think that Dr. Kendi did. So that this one not remove. Sorry, or let me stop sharing, Jerry, and share again. So once I share again, to not appear. Yes, want to use this example to illustrate. We still start from that mean deviation to illustrate standard deviation and variance. Let's example, we use a manageable sample size for illustration so that you can understand. Let's see. This one is trying to tell you how you compute, understand variance, and standard deviation from the mean. Okay, let's say we have 5 persons. And these 5 persons, their friends, they run a short distance. The time it took each of them to run through a short distance in seconds. So, number one, no, we have arranged the value in ascending order. So, 3, 4, 5, 6, 7. That is the x. So, if you add everything together, it gives you 25. That's sigma. So, when you see sigma, x means addition of x, 25. If you want to calculate the mean, you see addition of L, which is 25, over N, which is the sample size, which is 5. So we give you 5. So the average distance among them is 5. Now, that is measure of central tendency. Measure of spread, we want to know. The first one here is deviation from the mean, which is the mean deviation. So in the mean deviation, you remove the mean from each value. The value is x. Look at the third column now. Deviation from the mean. The value is x, and bar x is the mean. You know, I've already told you before that the statistic, the summary of sample, is represented by Roman alphabet. Bar x is the mean. So now, if you remove 5 from 3, it gives you -2, because the mean is 5. You are removing mean from each value. 5 from 4, it gives you -1. 5 from 5 give you 0. 5 from 6, 1. 5 from 7, 2. You will see that the value that are, when you remove mean from the value that is lower than the mean, it gives you negative. The one that is equal to the mean, it gives you 0, of course. The one that is more than the mean, when you remove mean from it, it gives you positive. If you try to, this is what we call deviation from the mean. That is, each value, how do they deviate from the mean, different from the mean. Now, this deviation from the mean is not useful further, because if you try to add it, it gives you 0. If you try to get sum of deviation from the mean, always give you 0, because mean is in the middle now. As much that are less than the mean are greater than the mean. In that situation, you see that when you now remove the mean from it, the negative and the positive, they cancel. So if you try to add it, it gives you 0. So intelligent people now say, oh, what should we do? You cannot be stuck here. They now say, okay, let's do something to that mean deviation. Let's square it. You know, when you square a number, it removes the negativity. So when you square this value, the last column is square deviation from the mean. And you see, square deviation from the mean. So when you square it now, all those negative will leave. You'll be able to add it. When you add it together, like for this one now, we do square division, sigma, addition of x minus x bar square. That's square division from the mean. It gives you 10. Now, that's a very good one. But just like, you remember, when you look at the whole value, each of them, the original value, 3, 4, 5, you add it together, give you 25. It's not the 25. You now want to know average. That is, averagely, among all of them, what is the average a number the second they used to run that place. So you calculate the average by dividing by 5. The same thing when you do square deviation, the total square deviation does not make any sense because I fly just like the other one. It depends, the size will depend on the sample size. It's just like the total number of value in column 2, 25. If they are more than this, the total will be more than 25. See, so the size, that total depends on the sample size. So the only meaningful thing you can do is to calculate the average, divide by the sample size to give you average. It's the same thing with the square deviation from the mean. The total number depends on sample size. What we want to know now, what is the average square deviation from the mean? Can you see now? Average square. Some people call it, what is the mean square deviation from the mean? Don't let it confuse you. The first, when you say deviation from the mean, that's deviation from the arithmetic mean. Then when you now say you want to know the mean deviation from when you now sum up the square deviation, what is the mean square deviation? When you have sum of the square deviation from the mean, what is the average? Which is the mean? Which is the mean square deviation? And that is the variance. And how do you calculate that? You know, in trying to calculate that average, you will not divide by the number, sample size, you divide by what we call degree of freedom. You need to understand the concept of degree of freedom. And that's why, let me quickly explain it here. So, though, let me first use crude way of it before I use this one to explain it. If I do my workshop or lecture physically, I usually arrange here for students or participants to come and sit down. I will use it to explain the concept of the degree of freedom. Let's assume that we are in a class now, or let's say the illustration I actually do is that you have a board meeting to attend. 5 of you have a board meeting to attend, and in that meeting place they have arranged 5 chairs. And in this meeting, maybe there's nobody there's no special set for anybody. You can sit on any chair, 5 chairs. The first person that arrives, we have choice to make from 5 chairs. Because if you sit on one, doesn't like one chair, color of the chair, the way it looks, he will not go and sit down on it. He will sit down, choose one, and good. He has choice to make among 5 chairs. The second person that will come, we have choice to make among 4 shares, the remaining 4 shares. The third person, we have choice to make among the 3 shares. The fourth person, we have choice to make among in between 2 shares. The last person that will come does not have choice to make. It's not a matter of maybe he has only 1 share. You cannot say he only 1 choice. That 1 share, you cannot make choice because that's what it means. So for the fact that out of 5 people, 4 can make a choice to vary where to sit, to change where to sit, the degree of freedom is 4 out of 5. The last person does not have that choice. So actually, that is the concept of degree of freedom. It's just like also you are at home now. The food is in the pot. Anybody come, dish food and eat. The last person now say, who has no, you can say you are the only person. So because if you are not the only person, if they say there are still 2, you see how you have to gauge, you have to just to say, no, let me reduce, you cannot take everything. But you can take more, take less, depending on what you want. But the last person, he doesn't have choice to say, I will take more or take less. He says it's your own that remains. Can you see? Now, out of the total number in the family, only person, that last person, does not have choice to determine whether to increase what you want to eat or to decrease it. Now, the way it works in the real life is this. Or another way, after you have done maybe you did the meeting now, they now say they gave you 400,000 as just for your transport or for your distance. If I ask you now, how will you share the 100,000? People will say 20 now, 20,000. That's average. You have just calculated the average. If you share, if they share that money anyhow, if you see add all the money together, it's still 100. If you divide by 5 of them, it gives you 20. That is the average you are okay. So average assume that everybody is the same. That's one. The crudest model is average. It assumes that everybody is the same. It's just like when they, okay, let me not let him talk much about that. But the issue there is that if they are actually want to share the money, the first person, maybe the most senior, may decide to take 40,000. He can decide, and the next senior may decide what he want to take. Until the last one, the junior, doesn't have option. So the degree of freedom is still, can you see, is the number of entity minus 1 is the degree of freedom. Even though when you want to apply it in the statistic for t-test for chi-square, there's a variation in the way you apply, but the logic is still the number of items, the number of the entity minus 1. That is, so, and the way it is applied to this situation is that in the population, the variable, well, that's why you call it the characteristic you are studying population vary a lot. For example, now, as you are here, even all of you, your weight vary. Some of you may go lean, you lose weight over some time, later you may gain it back. That time you lose weight, some people are adding weight. In a population, in a defined population, in a particular period of time, the mean weight, the average weight in the population is constant. It's a constant. But the individual weight vary. As some are losing weight, some are gaining weight. So at the end of the day, even though the person, some people are losing, some people are gaining, at the end of the day, the average weight in the population is constant. But what changes is individual weight. Now, in the population, naturally, when you have already, if you look at it now, look at it, so we calculate the mean. By calculating the mean, we have already fixed, okay, we already fixed the total. How? We say 20, mean, there are 5, and mean is 5. That shows that the total value is 25. So that means, I've already told you that the mean in the population is constant. Though this mean we calculated here is a proxy, it's the sample mean, but that is the proxy to the parameter. So by calculating it, so when we come here, we now did deviation from the mean. We have already, because the mean is fixed, the total number of entity is fixed. It is already fixed because we have the mean and the total number. So all the elements, all of them cannot vary. All the elements cannot vary. So that is why out of these 4 values here now, all of them cannot vary. So the degree of freedom, how many can vary? 4 out of 5. So when you are dividing, you are not dividing by 5, like the way you calculate the mean, you divide by the degree of freedom. You divide by the degree of freedom. So you know that when you are calculating the mean, why you have to divide by the total sample, the individual value vary. All individual value, all of them can vary. That's why you see consider the number, the sample size. But when you have already calculated the mean, because the mean itself does not vary, and it's involved in calculating these deviation, all those stuff. So all the elements cannot vary. So only the one that can vary are the number of entity minus 1, which is the degree of freedom. So you now divide that sum of square, the sum of square, you now divide it by the degree of freedom to calculate your mean square deviation. So this thing I'm just explaining now. Look at this last column, sum of square. Can you see? Sigma is the sum. X minus X bar square. That is the square deviation. If the square deviation, they call sum of square. If you, by the time you get, I've already told you mean. Very, very important. Standard deviation, variance, they are what you use in advanced statistics. When you run regression ANOVA, you have heard of sum of square. That is it. It's the same thing. That's the origin. This is the origin of this sum of square. Can you see now? X, sigma X minus X bar square, which is sum of square. So the average sum of square That's it. When you now divide this form of square, you now mean square deviation from the mean. You calculate the average, divide it by 30 by divided by the degree of freedom. That is the variance. That's why they say variance is the mean square deviation by the mean. Look at it here. Variance, which is S square, is sigma x minus S bar square over n minus 1. When we did it, it gives you 2.5. Now, you know that the essence of calculating this variance measures dispersion is for us when we have known the measure of center tendency, which is the mean. We want to know the measure of dispersion. That's why we usually quote mean plus or minus standard deviation. You cannot use variance because if you look at it, we are square. If your mean, for example, now, this example we gave now, we say the time spent to run a distance. Now, this time is measured in seconds. So this variance will be in second square. The mean will be in second because it's the same unit as the original. But the variance will be in second square because we have already somewhere here. So we cannot measure our mean with a unit not in square, and the standard deviation will be variance. The measure of dispersion will be in square. So, you know, since the step in producing it is to square, so in reversing it, you now calculate the square root. When you calculate the square root of variance, that is standard deviation, so that the unit will be the same thing with the mean. So we calculate the standard square root of variance. It gives you standard deviation. Here now is 1.6. So you can now code that, oh, the time is mean 5 seconds plus or minus 1.6 standard deviation. Can you see now? Plus or minus 1.6 standard deviation. So if you look at it mathematically, to be fair with you, let's say we lose that deviation within square. We just use this middle one, deviation from the mean. If we neglect the sign, let's say all this minus, you just neglect it, just add it together. It gives you 6 divided by, let's say 5. We didn't talk about all those, or even the 5. It will still give you 1 point something, but it will not be mathematically correct. So you see, this is standard deviation, which is square root of it. So standard deviation and variance, they are the same. The both of them are measure of dispersion. It's just the unit that makes them different. It's like water and ice. So if somebody say you need eye block, you should put water inside fridge, you get your block. If somebody say you took my water, is my water, allow the ice to melt, it gives you the water. So it's like ice block and water. The variance and standard deviation. Want to calculate variance, you square standard deviation. Want to calculate standard deviation from variance, you square root of variance. Now, I think I've discussed this one. Now, we have talked about the measure of dispersion now. So that is the logic, the origin of this. You now say mean plus or minus also standard deviation. Now let's look at measure of relative position. So the method of relative position is not new to us. You remember when we were in primary school, for people that went to village school, not all this one now. Even they still do it now. His position, they look at what is your position in class. So it's your position that you arrange the score from the smallest or from the highest to the smallest. The highest is number 1. It's the same thing. If you have value, you arrange it in ascending order. In ascending order, you want to know which position somebody is. It's not like the position they use in the class, because in the one in the class is the one that had the highest score, that is first position. Here now is the smallest to the highest. To know the position. Now, let's say you know that let's standardize it for it to be easy for you. Let's say the score are 100 in number. 100, they are 100, maybe weight, 100 weight. You arrange them for 100 people. Now, which value of this weight is in middle, which is number 50? Which value is in number 25? Which value is number 75? Which value is 100? But that's not actually the way. The logic behind this thing is in knowing the position. This measure of relative position is called quintile. Quintile. And there are different approaches to it. Now, the simplest one is if you divide, if I give you a loaf of bread, you have twins now. You want to share it equally for them. You carry your knife. How many times will you cut it? Once in the middle. And that month is easy. That if you are to measure the distance from one end to the other, the middle, which is 50%, where you have measured 50% of the bread, you cut it. So the line that divides your DC into two is the median. Though we are not showing that one here, but that's the simplest one measure of relative position. Is the median. Now, the line, if for the it will be triplet, you want to give two quadruplet, it's 4 people you want to give the bread. After you have cut it in the middle now, equally, you carry the other one, you cut it. You carry the other one, cut it. You are cutting in 3 places. To give you, if you remember the first one, you cut it in 1 place to give you 2, to divide into 2. You need to cut it in 3 places to divide it into equal 4, 4, 4. And you know the 4 part of something is quarter. So the line that divide them into 4 equal pie into 25, 25, 25% is quartile. And you see now, median is the one that divide into half, 50, 50. The line that divides it into 4, call them quartile. And there are 3 lines. If you remember, I told you we have the bread. You have to first cut it in the middle first. Then each of the half you cut it into in the middle. So you have 3 places you cut it. Then it give you 4. So here now, if let's say we arrange this thing, we say there are 100 now, 100 people. We have arranged ascending order. So the one in the number 50, that's the middle. That's the median. Then if the first half, you put in half, number 25, that is the first quartile or lower quartile. That middle one, the median, is the second quartile. The third one will be at 75%, which is the upper quartile. So those quartiles are lower, middle, upper quartile. So it divides the distribution into 4 equal parts. If you want to divide into 10 equal parts, you have to cut it in 9 places. So there are 9 lines that are divided into 10. They call it decile. That line is called decile. Decile. So the one that divides into 100 equal, that is percentile. There are 99 lines. Percentile. That's the same thing as percentage, you use percentile. I think it's very, very, so if you, the way they used to know is that, okay, if I go to the number 50, what is the value? What is the weight? What is the score? What is the weight that is in number position 50%? That's the middle quartile. What is the weight? The value that is in position 25%? That's the lower quartile. What is the value that is in position 75%? That's lower. So that's what we usually use. And another measure of dispersion of spread here is interquartile range. That is the difference between the upper and the lower quartile. That is 75 and 25. And they usually use it sometimes. It's better than the range because the range is affected by outlier. Then those extreme value, if you do interquartile range, the extreme value on both lower side and lower side have been removed by just know, okay, what is the value between the first quartile. You know the first quartile is 25. So the extreme value you're going to have that is lower will be below that. The upper quartile is 75. The extreme value that you're going to have that is higher will be above that. So in between the two, we call it interquartile range. It's a measure of, is to remove the effect of outlier. They use it as a form of measure of dispersion when you want to remove the effect of outlier from it. Now, there's something here in most of the time, I've already said, we use this quartile, but there's one, whenever those who are doing research in earth economists or economists, generally, they want to measure socioeconomic status. So they use quintile. You know that the name for all of them is called quantile. The quantile, it can be quartile, can be decile, can be percentile. It can be quintile. That quintile, instead of we having 3 lines, dividing them into 4 equal parts, we have 5 lines that divide them. We have 4 lines rather, 4 lines that divide into 5 equal parts, into 20, 20, 20, 20, 20. Instead of 25, 25, 25, 25%, it divided into 20, 20, 20. You know, 20, 20, 20. From 100% will be 5 places, and it's 4 lines. They call it quintile. So that's why they want to know when they are doing, what is the proportion of the lowest 20% socioeconomic, the poorest, that's the poorest in the society, lowest 20%. Then the next 20%, the next 20%, this is the middle, the next 20%, and the upper 20%. So they use quintile. Now, cumulative frequency polygon. This one just show the upper quarter, lower quarter, so that you can see. If you plot the ogive graph, you remember when we were discussing how to display this data in the last lecture, I talked about the graphical. One of them is the cumulative. We have already talked about cumulative frequency. We said that you are adding each class to where you have arranged as any other. The frequency of one class, you add it to the previous one. The next one, you add it to the previous one. So instead of the frequency to go down for each class, it will be going up. It gives you this sigma curve. So if you, from here, you can actually know the position 75. The score that corresponds with position 70, because this one mark is talking about mark. You score in class on a scale of 100 to 100. The frequency, the number of people, which has been expressed as percentage also. So position 75 on the frequency corresponds with 70 mark 70. Can you see? Position 25 is 45, mark 45. Can you see? So in those days, when you do this statistic, that's what you measure on the graph. What is the median? The median value is 60. So this one is just to, now we talk about measure of distribution shape. We have talked about measure of relative positional shape. There are 2 of them. The shape just, though, the shape also is not far from what we have discussed before. Majorly, he talk about the effect of outlier, then also talk about the variability. So there are 2 measures of distribution shape, skewness and kurtosis. So the skewness measure the asymmetry. If you look at the middle, the upper one, and you see the middle, that's the normally distributed. But if you see the one that is skewed, that has negative outlier, it's negative. That is, it has some value that is simply smaller than the rest. That's why it's skewed to the left. So this other one has some value that is simply higher than the rest, is skewed to the right. So when there's skewness, it will be skewed. It will be asymmetric. So skewness is a measure of distribution shape. Then thickness of the graph is the kurtosis. So if you look at it in the middle, that's normal distribution. You see one that is flat, is one that is peak. So the one that is flat is called platyphotic distribution. The one that is peak is called leptokurtic distribution. What causes it? There are some attributes that naturally they are close. They don't vary much. They are close to the mean. That is, they don't vary much among population. If you are to compare weight and height now, height don't vary like weight among people. You see, you don't see much difference in the height of human being compared with weight. Weight very much. You see people skinny, while some people are big. So if you are to plot the graph of height and weight, then the distribution, the height will peak more than weight. So there are some situations where the thing is it may be apart from the attribute, maybe your own data set, maybe the value are far apart, so it will be flat. If the value are very close, it will peak, maybe a similar peak. So that is the measure. This one they are just showing different other shape. Just leave it. So that's the end of the lecture. Any question? So that's the end of how you summarize quantitative data. It's quite interesting. So any question? Any question? It's very simple. You can chat. If you have question, you don't want to talk, you can share. You can ask your question. There's nothing like embarrassment here. If you want me to throw light, I will throw light on it. So, but I know that it's very straightforward. But if you have question, you can ask. Okay, there's no question.